Hi, and welcome to Weapons of Math Instruction. Back in March of 2021, I posted my very first videos on this channel, and there were 7 videos in celebration of Pi Day. In the 7th of those videos, I stated the value of this beast called the Gaussian integral without showing you how to calculate it. Let's set the Wayback Machine for March 22nd, 2021 and see what I'm talking about. This is the well-known Gaussian integral. Evaluating it requires techniques from Calculus 3. And I could spend a whole video explaining how to do it. Just so we don't go too far down the rabbit hole, I will at this point tell you the answer and ask you to remind me that I owe you a video on this integral in the future. This integral evaluates to the square root of pi. So here's the integral that I promised to show you. No one ever called me out on it, so I'm calling myself out today. In this video, I'm going to show you how to calculate this thing. So let's go back to the present and get to it. So here's the Gaussian integral, written in the variable x instead of u. It doesn't matter what variable we use. The value of the integral doesn't depend on it. And that value, I'm calling it I on the left side. So this is not an elementary integral, meaning that you can't find an antiderivative of e to the negative x squared in terms of elementary functions. So what we're going to do is square this integral, like so. So on the left, I have I squared, and on the right, I have 2 copies of I. One I just wrote as I, and the other one I wrote explicitly. So this I here is a constant, so I'm going to bring it inside, like so. Here's the I. Now, remember when I said that it doesn't matter what variable we use for integration? Here, I'm going to explicitly write that I that I brought inside, only this time I'll use the variable y. I can write this as an iterated integral, like so. Now, at this point, you must be thinking, bruh, what's wrong with you? You took this butt-ugly integral up here, and you made it even uglier down here. Just bear with me a sec. So first, note that both the x and y integrations go from negative infinity to positive infinity. What that means is that the region of integration is all of R2. It's the entire xy plane. What we're going to do is switch from the Cartesian coordinates x and y to the polar coordinates r and theta. So to do that transformation, we note that x squared plus y squared equals r squared, and the differential area element dy dx equals r dr d theta in polar coordinates. So if I let r go from 0 to infinity, and theta go from 0 to 2 pi, then the region of integration will be all of R2 once again. Got it? Good. Now we're running out of room, so I'll continue this calculation on the next slide. Okay, so in polar coordinates, I squared equals the integral from 0 to 2 pi on theta, and from 0 to infinity on r, of e to the negative r squared r. Now we're getting somewhere. This r integration can be tackled with a u substitution. So we let u equal r squared, and then du equals 2r dr, or r dr equals du over 2. So here, I've taken this factor of 1/2 right here, and put it outside the integral. And note that as r goes from 0 to infinity, u also goes from 0 to infinity. So the limits of integration don't change on the inside integral. And this integral is elementary. The antiderivative of e to the negative u is just negative e to the negative u. So here, I brought the negative from the antiderivative outside. And this is an improper integral, so I really should take the limit as some parameter t goes to infinity of e to the negative u evaluated from 0 to t. And in this step, I've evaluated the bracket, so I get e to the negative t minus 1. And as t goes to infinity, the decaying exponential term goes to 0, leaving only the constant term, negative 1. So this negative 1 times this negative 1/2 gives me a positive 1/2 outside the integral. And this is the easiest integral in the world. If you integrate d theta, you just get theta. So we have 1/2 times theta evaluated from 0 to 2 pi. And of course, if you evaluate that bracket, you get 2 pi times 1/2 gives pi. So I squared is pi. Now, we didn't want I squared, we wanted I. So we will take the square root of both sides. And we get I equals the square root of pi, just as advertised in that video from March of 2021. Thanks for tuning in to Weapons of Math Instruction, and I'll talk to you again soon. Everybody, if you enjoyed this video and want to see more like it, then please do follow me on my socials. You know you want to.